Hey everyone, my name is Shourya. I'm joined with Ashish. We are software developers at AWS. Today, through this presentation, we'll be touching upon a few points through which you can monitor your cluster in a better way. So, when we say monitoring, these are mostly proactive or sometimes reactive steps that you can take so that you don't end up in a data loss situation, or at the same time, you don't encounter a downtime when operating OpenSearch at a massive scale. So OpenSearch, as we have seen, it ends up hosting some of the business critical workloads. So it's imperative that we have some monitoring in place so that if an OpenSearch cluster goes down, it doesn't bring down the business logic along with it. So we'll go through some of the situations or some of the APIs that we can use, and Ashish would be going through some of the root causes or some of the crux of why things tend to break in OpenSearch. So some of the common challenges, we probably would have all seen this while using our OpenSearch cluster is red cluster. When we say red cluster, the cluster is signifying that one of the primary nodes on that were present for an index that is lost. It is not able to, the cluster manager is not able to find the node which was hosting that chart. Usually, most of the times, I would say 9 out of 10 times, the reason behind that is data nodes that are dropping off and leaving the cluster. We'll see why data nodes under what situations can crash. The service running inside the data nodes would crash, the OpenSearch service I mean, and we can see how we can better predict that, if that's going to happen. The other one are request timing out. It can be a dashboard that's timing out that you have set up on OSD. It can well be some of your indexing requests from Fluentd, Data Prepper, whatever you're using to ingest data into the OpenSearch cluster. They are timing out. Same time, search requests which you might be making from your own application, that might also get a timeout. And we'll try to address the root cause behind these two, which is usually imbalanced cluster. So when we say imbalance, these can be imbalanced in terms of resource utilization, in terms of storage, or probably in terms of the amount of requests that we are getting. This at the end of the day is slightly related to how you shard your data, but yeah, we'll see it later on these in this presentation as to what can happen if that's the case. So this is the state that we want to be in. We have a cluster that said it's green. It has 3 nodes running, all the shards are active, some X number of primary shards. The cluster is saying I'm good, I'm green. But this is the state that we do not want to be in. When the cluster says that its health is red, the cluster is signifying that in turn, some of the data that was stored in the cluster is lost. The cluster health, instead of being a performance metric, this is actually a data availability metric that it kind of like signifies. This says that when the cluster is red, some of the data that you are querying or some of the data that are already ingested, it's lost. So in a red cluster state, if you are doing indexing, some of your indexing requests would fail. At the same time, when you are doing a query, you would get partial results out of the cluster. For the keen-eyed, you would see that there were 3 nodes that are running and now there are 2. So this is the reason behind why the cluster turned red. So according to the sharding strategies that we had, or how we had divided the index into the number of shards, one node that was hosting a primary shard, it went down and it never joined back the cluster. So the cluster is implying that, hey, the data that was present in that specific shard is lost. We don't have anything to recover it from. Some of the common suspects, obviously, OpenSearch, it's a Java-based application. When you start up OpenSearch, you set a certain amount of JVM heap. This can well be if you have, let's say, 16 GB virtual machine that has 16 GB of RAM, you might want to allocate 10 GB of Java heap, and if you run something else, you keep the rest of the 6 GB for that. Yeah, so when you allocate some JVM, some heap to the Java virtual machine, whenever memory allocation is going through, the Java virtual machine would in turn try to clear off any unreferenced points. So in that way, we call it garbage collection. I think probably everyone would be aware. So when garbage collection is not able to reclaim memory at the rate that it should, but at the same time, the fill up of memory is much more, which it's getting cleared off, then the JVM signifies that and crashes with an error called out of memory. It says that, hey, I need, let's say, 1 MB of more memory, but then the entire memory stack is full. There's nowhere it can go. So that is what in those kind of situations your data node would crash with an out of memory error. And I think this was also briefly touched upon in one of the other talks, the leader and follower checks that are coming up from and to the cluster manager. So this is a little bit harder to detect because this doesn't show up as an obvious issue in the OpenSearch metrics, but there are certain other metrics that you can go through so that you can well predict if you're going to encounter these kind of issues. Mostly these are related to network, and sometimes these are also related to disks. So I'm not sure if the log line is visible from here, but yeah, this is how the logs would look like when the cluster has, when the data node has crashed with an out of memory error. So the logs tend to give out a signal. So for example, if we check here, we can see that it says that it's attempting to trigger G1GC, that's a Java garbage collection algorithm. It says that it's attempting to trigger a G1GC, and then it says that GC did not help, GC did not bring the memory usage down. Whatever it was before and after, it's almost the same, or it's even greater. So these are the signals that the cluster gives out, and after that we see that it's terminating with an out of memory error. Again, so when we observe at what was the trigger point for this G1GC invocation, we can see that there was a search request that just happened before this. So something happened within that search request which resulted in using a lot of memory, and then it eventually went out. What happened within that search, we have seen from most of our day-to-day, whatever we have seen, most of them are because of large aggregations. So with aggregation, you tend to do a query, it brings up a lot of data on the memory, and then it tries to give you the aggregation results, right? So that in turn would result in your heap filling up. So these are some of the, we'll go through some of the preventive measures. Some of them are reactive, while others are proactive. So the first one, which as it says, that you should right size your JVM heap. So the recommendation is to typically have 50% of the RAM that your hardware or your virtual machine has, but it depends. It can go up and it can go down depending on what instance type or how your workload is. But that's like the best practice that is suggested. That's a reactive one. Now comes to the proactive one. So OpenSearch in itself has some inbuilt guardrails. So it tends to prevent these out of memory errors by using something called as circuit breakers. So OpenSearch in itself, whenever you're doing a request, it pre-computes the amount of memory that it would need to execute that request. If it goes over the guardrail limit that you have set, it would automatically go back and tell you a circuit breaking exception, and it would reject the request. So it tries to prevent itself from going down, but you would need to set those limits appropriately. So the default limit is 95%, but 95% can be a bit too aggressive at certain times. So yeah, it's better you take a call, see what circuit breaker limits you need to enable, and then that way you can protect the cluster from ooming out in itself. So the other ones, the rest two are related to search. So whenever you are indexing some data, OpenSearch in itself tries to create a mapping out of it. So imagine this mapping to be as like a schema when you use a SQL database. So basically you're defining what data type your field would be. By default, any string field is mapped to a data type called text. These text data types, they use a different data structure in the backend to do aggregations. So it imagines that a string is usually a complete sentence. So in situations like that, it's not always very effective in doing aggregations on those entire sentences. So if you end up doing something like that, it triggers something called as field data. This is not disabled by default. This is enabled by default. Sorry, it's not enabled by default. You'll have to enable it. But field data is lazily loaded into the heap. So as and when you keep on doing those queries, it would keep on building your JVM heap, and they're never cleared out unless and until you manually go ahead and clear it off. So it's recommended that you don't do aggregations on these type of fields, and instead OpenSearch creates a sub keyword field. So it takes a part of that sentence and it creates a keyword field against it. Whenever you're doing an aggregation, just ensure that you're using that keyword field. If that keyword field is not according to what you like, so for example, you have a long sentence, you want to pick up certain stop words from it to create the keyword field, you can define your own mapping type. The default behavior is it would take up first X characters. I think the limit is 100. I'm not sure on that, but yeah, it takes up first X characters and creates a keyword field out of it. If you want more characters, feel free to have your own mappings. And yeah, so even after doing all these, we have found out that there can still be chances of row queries coming in and then taking up the entire Java heap, and then the system goes into a enum state. That is where we came ahead with search back pressure. So search back pressure effectively means that it calculates the amount of Java heap that it's going to consume. It also takes in CPU into consideration, by the way. So it computes that whether, if by executing this query, if I'm going to go over the certain set limits, it would start cancelling out all the query tasks. So a query, when it comes to a node, it can span out into multiple subqueries. So this has that knowledge. This goes ahead and it tries killing off all those tasks so that it can reclaim back the memory and prevent an enum situation. Okay, this is, I think this is again a bit too small, but I'll try to keep, I'll try to explain this in a little bit. So cluster manager health checks, like I mentioned, these might not show up immediately on the metrics, but these are like the gray side of things. So it can either be, so you have a failure state and an active state, but then things tend to go wrong when you're in that gray state. You never know whether you have completely failed or whether you are active. So cluster manager health checks are designed to ensure that systems in that gray state are kind of fenced out. So the cluster manager goes ahead and pings each and every one of those data nodes by doing some health checks. The data nodes tend to do the same thing back. If at any point of time it fails n is 3, so n number of retries where it doesn't get a successful response, the cluster manager kicks that node out of the cluster, mentioning that this node, whatever has happened with this node, I don't want it to serve requests because it's not in a sane state. So cluster manager health checks can end up causing a lot of trouble when we are not really sure why that happened in the first place. So like I mentioned, these can be very easily network induced failures. These are the basic health checks that it does. Network induced failures. So if you have a network partition between the cluster manager and the data nodes, so these two won't be able to talk to each other. If you're in a cloud environment, these would be easy outages and all these type of things. So in network induced failures, you would end up seeing these kind of situations happening. And obviously noisy neighbor hardware failures are inevitable, right? And the other health check that it does is disk. So if it sees that the underlying disk, it's slow, it's not responding to requests, it thinks of it as a failed data node, because then the indexing requests coming into that node won't get served properly. So this fencing is still there. So the cluster manager does a single health check on each of the data nodes by writing a piece of file. If it goes below a certain threshold, it says that this disks are not functioning properly. I'm going to go ahead and remove this off the cluster. So these are the things that you might not see if you're only monitoring OpenSearch metrics. So we'll see how you can monitor them. OpenSearch comes out of the box with performance analyzer. So performance analyzer, this also this amalgamates all the OS level metrics and the OpenSearch based metrics together, and it kind of like puts it together in a single API. So performance analyzer has its API on its own. It's recommended that you poll that API to get the metrics and you put it in a TSDB. This can be InfluxDB or any Prometheus or any TSDB that you want, and then you set up alerting on it. So once you have proactive alerting on these kind of situations, you should be able to take a calculated decision as to what you can do. So these are some of the networking KPIs, as we say, key performance indicators. So this has both IPv4 and IPv6 communication metrics. The IPv4 ones, the packet drop rate ones are the ones which are like the worst things. So if packets are dropping, then there is obviously something wrong, some network level issue between two entities. So if you're seeing packet drops, or if you're seeing that the packet rate has also gone down, it's high time you go back. You either go ahead and do something on your network side, or you replace that node. There's some hardware issue. And obviously, when you're running on a cloud environment, the cloud providers would tend to protect their systems from some bad actor coming in and taking up all their bandwidth. So they would have their own throttling logic. So these throttling logics would also come into picture when you are probably not set up in the correct configuration. So they would have different configurations that support different bandwidth. So if you go over that bandwidth, they'll start throttling it. That in turn might show up as a node drop. which is something that can be monitored with these metrics, especially the network saturation and network throughput metrics. Storage, as thing suggests, this kind of like shows you metrics, mostly like IOStat and all those kind of things, which would give you a picture as to how your disks are functioning. So if you have a very high disk wait time, so the OS, the writes on your disk, writes and reads are kind of like waiting. So your disk serve time is very high. So disk is not reading and writing at the same rate as it was before. Or you are producing more requests than the disk can support. So when I say disk can support, obviously your cloud providers would have their own managed disk offering, right? So they would have their own throttling limits. If you're getting throttled that much, then at the end of the day your wait time would increase. Again, that's a node drop. Alright, so we briefly touched upon why node drops are kind of like happening and that might end up causing a red cluster. I'll move on to request timing out. This is something that probably some of us would have seen while doing stuff from OSD. You load up the discover page and it says network error, it's not able to fetch any log. And again, some logs on your client side, which is trying to ingest data. It says OpenSearch operation timed out, everything is timed out. These are a little bit straightforward to diagnose because the cluster tends to give out blatant hints, like something is wrong. If you monitor the correct metrics, you should be able to guess why this is happening. So what we have for this, we have slow logs. So both indexing and search, they publish slow logs. Node stats, this is like the prime API through which OpenSearch exposes all the metrics. And we have hot threads. So whenever you have a CPU usage spike, this is your savior. So hot threads would have all the data that you need to find out what was the reason behind that CPU spike. Again, as you can see from the log, so in search slow logs, both the query and the fetch phase are kind of like gone ahead and they are printed out separately. So in brief, each search would have a query phase and a fetch phase. When you do a search, the system goes in, it tries to figure out in the query phase the documents that it need to fetch, and in the fetch phase it goes back and fetches those documents physically. So the query phase and the fetch phase are logged out separately in search slow logs, and the best part about that is it also prints out the query that it was trying to execute. So you can go back, you can see that this query at this point of time took this much amount of seconds, and you can troubleshoot that from there on. For example, if you see this query, this says that it took 40 seconds. So any client application that was waiting for a result of these queries, which has a timeout of less than 40 seconds, 30 seconds is the default timeout by the way, all those requests would time out. Now we have the reason, we have kind of like the slow log which denotes that requests have timed out, but now it's time to figure out why queries were slow. There's a possibility that you fired up something, you fired up a query and you don't know why it was slow in this execution phase. This comes to the rescue. You have a profile API. So you use your query, pass on a profile parameter, and the query, the OpenSearch engine would go ahead and profile all the stages that your query is doing. So in short, each query is subdivided into multiple subqueries. So you do one, you can do an aggregation, you do a lot of things. So it would time each and every step that it has taken to completely execute that query. So for example, this one says that it has a higher rewrite time. So this is just a gist of all of these. So it completely says that 112165 was taken and this was cancelled. So this has a huge output. You should be able to guess which step is taking the most amount of time, and then it's back to the drawing board to ensure that you are able to optimize that query further. This is mostly from the SQL one. This is like a query plan. It would show you the query plan. And obviously we have query insights. Query insights was purpose built for these kind of scenarios. They take the telemetry of all your queries. This plugin would put it into an index, and this has an OpenSearch dashboard, kind of like a dashboard out of it. So if you are monitoring this daily, you should be able to figure out what time your queries are slow or which specific query patterns are slow, so that you can take steps to kind of like optimize them. So if you see here, it also shows memory usage, CPU time, and the time taken, the latency one. Then you go on from there. Indexing slow logs, it's the same thing. Indexing doesn't have multiple stages, it's a single stage. So it shows off the time taken and the document body. And you can go back to the drawing board and figure out why that document took X amount of time to be ingested. These tend to happen when you have a custom analyzer set or you have multiple scripted fields. So when you say a scripted field, you can have 2 fields in your document. You probably do some, you take those fields, you want to create a 3rd field out of it because you're not able to get that from the source. You write a specific script that would take in those parameters and create a subfield for you. If those scripts are slow, that might end up slowing down your entire query, your entire indexing request. At the same time, analyzers, because it has to run its own logic to kind of like tokenize the entire data, that can also cause some slow queries to come, slow indexing requests to come in. Node stats, this is the powerhouse of everything. This has all the metrics. I'll briefly touch upon what node stats does, and then when Ashish would take over, he has a complete slide through which we would see that how node stats comes in handy in these situations. It exposes thread pool metrics, the number of requests that are queued, they're rejected, they're completed. All these things, they are shown point in time. So like I mentioned, if you want to use these metrics in, like if you want to observe them over a period of time, you can use some of the open source collectors. So OpenSearch has its own Prometheus collector. So you can use those collectors, get these metrics in a TSDB, and then you can figure out what went wrong if you are trying to figure out why your request timed out at a specific point of time. And again, hot threads, like I mentioned, this is a powerhouse. This would show you the entire call trace and the total amount of CPU that was taken up. Why the call trace is important is that so you can go back and figure out what exactly happened. So if you observe this call trace, it says that there is some 92.9% CPU utilization because of some scoring logic that is taking up that much amount of CPU. So probably you should be able to narrow down what exactly caused this. So some scoring logic is causing it. We should see what kind of scoring logic we are using in our queries. Again, this might not show up completely, but this is like the troubleshooting flow as I have discussed. So you check from slow logs, you figure out if it's a search request, you profile it. If it's an indexing request, you check for custom analyzer and scripted fields. If you are not able to find anything specific from slow logs, or you don't have them enabled, you can go back, you can check node stats. If it's high CPU utilization, you check hot threads. If it's high heap usage, we recommend taking a heap dump so that you can at least figure out what caused that excessive amount of heap utilization if you feel that that shouldn't happen. And when you are opening up an issue in the GitHub, OpenSearch GitHub, you can attach that specific heap dump, or you can analyze it yourself. So that also comes in handy. Again, when we say we are monitoring or polling certain metrics, excessive of everything can be an issue, which we have seen tends to happen when our users are polling these APIs at a very high rate. So node stats, the call internally goes to the cluster manager. So if you do, let's say, a request per second, that's exerting an extra load on your cluster manager. So you should use it judiciously. It's better to use it, like if you're not using it, it's better to use it, so like let's say once per minute, or if you need more granular metrics, maybe twice per minute. But anything over that, you might end up straining the cluster manager. You are more than welcome to scale the cluster manager as much as you want, so that you can have those extra set of extra granular metrics, but obviously that comes with its own costs. And yeah, extremely slow log threshold. So when you set up slow logs, you'd also have to define a threshold for that slow characteristic. So for you, slow may be some query that takes more than 30 seconds. For customer or for user or for anyone that you are using OpenSearch with, they might have a slow threshold which is like 10 seconds. So you should use that judiciously. What people tend to do is they tend to set up slow logs at like 1 second interval, and then you end up printing a lot of logs and then you run out of storage. So use that judiciously. Figure out if you are what exactly your slow threshold would be, and then work backwards. With that, I'll hand it over to Ashish. Up to you.
Hello. Hello. Hope I'm audible. All right. Yeah, thanks Shourya, and thanks everyone for attending. Good evening everyone. So we discussed about two of the issues, right, where we see the cluster going down or request timing out. Mostly they are not due to that all your cluster is completely utilized and you're running out of resources. Most often it is the imbalanced cluster. Let's see the spectrum of how your cluster can be in. First is a balanced cluster. Your shards are evenly distributed. Your resources are also evenly distributed, and so does your disk, right? So everything is looking in order. If this cluster goes and everything is running high, that's a good sign to scale out or scale up your cluster. This setup is more predictable because you know if you add or throw more nodes to it, things will work as expected. But that's not typically the case most of the times. What we often see is that the shards are not distributed evenly, right? In which case some nodes are running with high number of shards and some not with very high. There is definitely a shard imbalance, and due to that we see a implied non-uniform distribution of resources, right? So most often it is proportional, but very often we'll talk about the third, which is load skewed, where the shards and the resources, they are not correlational, right? So there's no relation between how many shards you have and how much are the resource getting used on these nodes. So these distribution of shards will look very nice to you, but the resource doesn't. And most often this is the one that is very difficult to debug and solve, right? And this requires the diagnostic tools that Shourya just talked about. So what we typically see, right, when the resources are going way too high is the distributions are not even, and this leads to many problems, right? Your search taking time, indexing taking time, nodes going down, cluster going into red state. You have too many replicas and still cluster doesn't work. Typically, the two dimensions that we just saw, there can be shard skew, there can be load skew. This is very harmful for your business because the performance is not predictable. You keep adding nodes, things don't scale well. You are not able to use the resource completely on your cluster, right? You are adding more nodes to it, vertically scaling. Things will probably work for some time, but again, you may end up in this state. And there's reduced cluster resiliency. The moment the hot node fails, the cluster takes immense amount of time to recover from that state, right? So it reduces your time to recovery drastically, and this is hidden behind healthy cluster, right? So everything looks green. The preliminary analysis that you do, everything looks green, but that's not the case, right? It's hiding deep beneath. So as I talked about, right? If there's hotspot on some nodes, your tail latencies or even your 50th percentile may just go so bad and you get impacted by the weakest link in your system, which is the node that is running high, right? So your indexing will see hit, your query performance will see hit, or any indexes shard that resides on that hotspot will see a hit. Your P90s will be very bad, right? I mean, you will not want to see such kind of numbers for your systems. Your throughput ceilings will hit very soon, right? You will not be able to scale much, and your resource efficiency will be maybe somewhere between 30 to 60%, right? So 60% of your resources just getting wasted. And obviously there's operational impact. Your fault tolerance is not that great. Scaling doesn't happen as you wished it to happen to. You may have planned, let's say, during your initial capacity planning by doing some testing, and when you went into prod, the numbers don't add up. You add premature hardware investment, that doesn't solve the root cause, right? So for the, like, to understand further, right, we need to see the anatomy of a skewed cluster, right? So if it is shard count skew, you'll see that some nodes are housing more number of shards and there is uneven resource utilization. You will also see in very simple APIs like cat allocation, you'll easily see that there is a definite problem, and this can happen maybe over time gradually, or maybe a topology change that you did which led to this, right? So these are easier to debug. But the load or the heat skew ones are very insidious. You cannot see them pretty easily. They would manifest as some nodes seeing more traffic than the others, right? And this is often tied with your workload pattern, right? There can be misleading configurations around indexing or sharding strategy that can lead to this. And yeah, this requires a crazy amount of investigation to identify, right? So why does this problems occur? Typically, they are, in no priority order, but yeah, there can be shard allocation settings which are not configured correctly. There can be a cluster awareness attributes, right? You are doing some maintenance, you added some flag for moving the shards, maybe during a BG or a rolling upgrade, and you forgot to undo the change that you did. And there can also be cases where you have poor disk watermark thresholds that tends to prevent the shard allocation, and you're adding nodes, removing them too frequently. The other kind, which is the load skew, there can be cases where you're having custom routing for documents, and the the variable that you're passing for the routing, that is kind of putting all the documents in one or few shards then compared to the rest. There can be time-based indexes where recent indexes tends to get more traffic. So although you have equal distribution of shard, the load will only tend to come on just few of the shards that are concentrated maybe on just very few nodes. And obviously the topmost being the unoptimized workloads, right? I think if you have attended session yesterday, some colleagues did talk about how you can optimize workloads with tuning the mappings, using the right set of search queries, right? So moving on, let's understand how we can debug these kind of issues. So we have the basic health assessment APIs, which are cluster health, allocation, shards, and cat nodes. So these are some simple APIs that you can use to just understand the overall health, and these set of APIs will help you detect shard skew very definitively. For the load distribution investigation, node stats is that smoking gun, right? It'll show all type of different signals that some of the nodes are bleeding, and obviously there are certain OS, there are APIs around providing OS metrics and stats. So detecting shard skew is pretty straightforward. You just run the cat allocation API. You can see here, for example, that some nodes have higher shards and some nodes have terribly lower shards. And this is interchange, but the one below is the distributed, and the one above is the skewed one. So you can see that in a perfectly distributed cluster, the shards are more balanced, and in a non one, it is very skewed. So typically in a healthy cluster, it should be maybe around like 5-10% and not more than that, the shard count. For detecting the load skew, the node stats API offers us very many set of information or metrics through the node stats API. Some of them being like on the indexing side or the search side, right? So these are provided at index level, where you can use the indexing or the search matrix, right? For example, here we can compare two nodes, the node 1 and node 3, and see easily that node 3 is hot because there are more queries and indexing happening on it, right? So it helps you to isolate or detect that node, and then we can talk about like using other set of toolings like hot threads to see what is exactly happening on that node, right? Similarly, there are information around thread pool. You can look at the active queuing or the rejected matrix. Again, you'll see evident differences similar to this. We have JVM stats. So node stats is that solution, folks, that like you definitely should look into, put it into your time series databases and look at the differences, right? Put alarming on top of that to know if there is some heat on some set of nodes. And similarly, like I said, OS process information, CPU, memory, hot threads being one, right? So once you know certain nodes are running hot, then you can start profiling, use hot threads, use maybe heap dump if need be, and see what exactly is taking up that extra resource on that node, right? The other API is the task API. It'll give you, like, let's say if you have a long running search query or maybe an indexing query, indexing task, then it'll show up like this is the time it has been taking, right? So you can see mostly if you have some skew, then you will see that one of the nodes have lot many pending tasks compared to others, right? So look out for these signals. Now, you using these APIs, you can detect the hotspots. Right now, the hotspots, first you need to identify. You may have identified now the node, right? With all these things that we did, we identified what is that different node that is problematic. With that, we proceed further and go a step within and see what is that index, the odd index out of all the indexes, using the node stats with indices breakdown, and the task API again can help you there. And once you have identified the index, then you can go again a step within and see which shard is problematic, right? So for that you have cat shards API, and then again node stats with shard level breakdown. So these, I think like these are the major set of, like there's not just this, node stats is even more powerful. There are more metrics and stats that you can see, but these are some of the things that you can use for maybe finding out P99 kind of issues that we typically see. Now, prevention strategies, using best practices around allocation settings, zone awareness, consistent settings across node, right? There can be cases where some of your nodes have OpenSearch YML, which are different from the rest of them, right? So you may see different kind of issues in such kind of setups. Monitor and alarm on any kind of skew, be it shard, disk, search, indexing, JVM, thread pool, right? Make sure you're sizing your indexes and shards appropriately, right? Review the indexing pattern, search pattern. Not all indexes are same. There are strategies around using multi-tenant, where you can use probably a routing ID and try to distribute load uniformly within an index for multiple of your tenants. Generally, it's not gonna scale where you have one index per tenant, right? So think from those perspective. Try to have similar size shards, right size shards, 10 to 50 GB would be ideal. Distribute. So our intention is to distribute heat across all the nodes, right? If it is not done in a manner, then obviously the hot node will become your weakest link in the system. And for indexes that have lot of traffic, right? If you have some index which is bringing in 99% of the traffic, always make the shard count as a multiple of the nodes so that you're able to distribute heat of that index onto all the nodes. Use index state management for applying the index settings, metadata, right? Creating lifecycle policies, rolling over indexes, offloading some of the data to snapshots that you don't use at all, and obviously with the shard and the replica configuration. And optimize the index mappings and search. This is like this talk, when talking about this would take maybe a day full. So there was one talk already which kind of went in much in depth about this. Now, the other thing is, if you still hit this problem, what do you do to mitigate? So many cases where you can just migrate a shard, the hot shard, right? You may not be able to fix the problem right away. So you want to do some workaround, and where you can use the cluster reroute API to move shards from one node to another. You can use split or shrink index APIs. This allows you to create more shards or collapse the number of shards that you have. Use the reindex API. This can come in handy if you want to get the right configuration and you're okay with certain downtime. Add index settings to limit number of shards, although this is not preferable and has other consequences, but this is one of the ways in which you can certainly ensure that no more than these number of shards of an index are sitting on a node. Yeah, with that I think pretty covered I think what I wanted to, and would open the floor for any questions and answers. Yeah.
Is there a feature called?
Sorry.
Hello. In OpenSearch, is there any feature called query queuing mechanism?
Sorry.
Query queuing mechanism. I mean.
Query queuing mechanism.
Yes. I mean, for example, I am getting 10 queries with a larger window. I mean, people are looking last 30 days of data. I want to allow only 5 queries at a time. So is there any way?
So there is no direct way of queuing as such. And to repeat, like you are saying, you have gotten multiple queries, and you want to queue some of them. Is that the question?
Correct. Yes.
So yeah, that is provided through some of the internal mechanism around thread pool queues, where we make sure that the active thread counts are only limited. But to give you a forward-looking answer, there is some work that is being done on query isolations, query groups that tend to limit the amount of usage by a query. So two sides, right? One is that you don't want to bring your cluster down, right? You still want that your cluster is running, and you may have to wait a bit longer because that's the nature of the query, that it will use resources, it will take some time. So yeah, that is the second, that it makes sure that your cluster is stable, and also keeps it in queue so that it is taken up within the timeouts that you set while making that query. Sure, you want to add something?
So there is no feature directly in the UI, right? So far.
There is no feature. There is no feature, but is there a, like, have you seen a case where, if you can maybe explain more, or maybe we can take that offline,
Sure.
and I would like to understand more on what you may have experienced and how we can probably mitigate that for you.
Sure. Thank you.
We use Splunk, and let's say I have a dashboard which has like 20-30 panels in it, and each panel is triggering a search. Now I want my dashboard to load, all the panels to load, but I don't want all the panels to be loaded at once. So in OpenSearch, if I open my dashboard, let's say I have 20 panels, so 20 search will be triggered simultaneously, and all those search will hit my cluster. So at some point of time there will be high search utilization. So if I could have configured it when I'm loading my dashboard, just load my panels 3 at a time, complete 3, then load the other 3, so that my cluster won't get all the load once I open my dashboard.
Yeah, definitely sounds like a use case to me. And I think yeah, we have mechanism to make sure that this cluster doesn't get bombarded with all of these requests. So yeah, good to probably discuss, maybe like if you have seen such case where dashboard brings down or probably doesn't load all the data that you're looking for, and I can go back and check if the dashboard itself does some things to maybe stagger all these requests and make sure that it's not hitting. But obviously any client can do that, and we have surge back pressure to handle the spike in load and make sure that cluster doesn't go down, and queuing is handled internally by the thread pool queues that we have.
Thank you. So one additional question. You talked about about the shard size and ISM policies as well. So in case of let's say when you have sized your shards, and I am having like a medium traffic coming to with multi-tenancy. I am having one shard per application, one index per application, one primary, one replica, and most of the time I'm getting maybe logs in megabytes. And for some reason they enabled trace or debug to troubleshoot some issue, and suddenly I'm getting like tons of logs. In that case, what happens? One of my data node is running hot because it is bombarded with all the traffic suddenly, all of a sudden. Now I can identify the node which is having trouble, but how do I identify which index is suddenly getting all of these traffic? I don't have a metrics at index or shard level.
Right. So we did discuss about one of the metric, which is okay. Okay, let me just talk about it, right? So we do have the node stats API, which you can use for resolving information to the extent of the index, right? So that way you can, if you are, let's say, monitoring the rate, indexing rate, you can definitely see that spike. Let's say, like you said, the debug logs have been enabled, so you will definitely see a spike there. And if you're monitoring that, you can definitely root cause and find out the odd man out here, which is the problematic index in your case. So that information
would have metrics available in the shard level.
Node stat, it is available in CloudWatch?
So we are talking from the API point. If your question is specifically on managed service of Amazon, yeah, that is something that is provided still through the Node Starts API, which can be yeah, checked.
Sure. I'll take a look. Thank you.
Closing session's about to begin.
Okay.
The whole event. So could you take the questions off
Yeah.
upstairs as you're walking in?
All right. Okay. Thanks, folks.
Thanks, everyone.
Thanks for all your